Hi folks, today I am bringing a Thomson DLP910VD home theater DVD panel. The VFD driver is a part of an 8-bit microprocessor which also contains the infrared receiver, timer, ADC, etc. So reusing it becomes a bit difficult since for now we cannot change the code resident in the microprocessor, which in this panel is a CXP82860. Also, its reusability is limited. It came back to life with half a dozen of the connections. We supply the panel with the voltage of the plus 5 volts DC, less 27 volts DC. In our case, we provide less 24, and final the voltage for the filaments that they original use, and according to the rules to avoid shadows, a voltage of the 3.3 volts AC. Also, they mention that both the less 27 volts DC and its GND poles come to the VFD border and pass to the board with the microprocessor. I do not see any point where the reference is created to GND. So, and as usual, we set the reference of our less 24 volts DC to GND in our protoboard. And for this, what we did has to connect our positive output of the plus 24 volts DC of the converter DC-DC to the general GND. We are left with the 0 volts of the converter being our less 24 volts DC, and which will be our negative power supply for the grids and segments, and which connects direct to the pin 45 marked as VFDP. As expected, after the process to ensure the presence of the power supplies is completed, the VFD did not display any data. Analyzing the pin identifications for the second time, it was possible to locate a pin marked as a standby. I also found a pin marked as a power down that goes to the pin number 4 of the MCU through a diode D505, and we suspect that this pin needs to have the plus 5 volts DC level because it has a resistor to the GND, which will be its idle state. After apply the GND level at the standby pin through a resistor of 2.7 kΩ and the plus 5 volts DC through the pin power down, also through a resistor of 2.7 kΩ, the transistor controller standby LED on the VFD board already showed signals of the life. When I pressed the source button, the VFD already showed some information. Now it is time to explore the actions present in the code resident on the microcontroller. Unfortunately, I did not find a 32.768 kHz crystal on the panel, which could indicate that it does not have a real-time clock present. After this step of checking the status of the VFD, we are ready for the next video using only the PCB where the VFD is with a simple driver.